Welcome to day 2 of the webinar on advanced ARDL and ARDL models. In tonight's class, we'll be discussing Fourier Augmented ARDL model. Fourier Augmented ARDL model. So the general specification for Fourier ARDL model is the same as that of Augmented ARDL model, with the exception that the Fourier terms is added to the Augmented ARDL model, or if you like, to ARDL model. So you can see, if you look at this clearly, you will see this general specification from here up to we have trade openness. So it's the same as that of ARDL model. But the addition of this term delta 1 sine into bracket 2 pi kt over t, that is big T plus delta 2 cos into bracket 2 pi kt divided by t, then plus error term. So these terms that are sine and cosine components, okay, together are known as Fourier terms. Once it enters ARDL model, that ARDL model becomes Fourier ARDL model. But because we want to use the augmented bond test, so we term this Fourier augmented ARDL model. Hope that is understood. And you can see this expression that is added is known as Fourier terms, which capture unknown smooth structural breaks in deterministic component of the series. So we have the definition of the parameters and variables here as it is being displayed. You can see then these same Fourier terms will also enter the bond test equation, also known as the unrestricted error correction model. So the Fourier terms is going to enter, as you can see, the Fourier terms has been added to the unrestricted error correction model. Okay, that is the Fourier ARDL bond test. You can see it's being displayed here. Then we have the augmented bond test. So as usual, augmented bond test has 3 tests. We have test A, that is overall bond test, F test. Then we have T test on the lag dependent variables, the coefficient of the lag dependent variables. Then we have test C, that is test F test on the lag independent variables. You can see, and we will be happy to reject the null hypothesis for all these 3 tests before we can conclude there is long-run relationship among the variables. Okay, you can see we have FAA RDL error correction model. This is the error correction model for this Fourier augmented ARDL model. After establishing the long-run relationship, we can now estimate our short-run dynamics that include error correction terms. You can see we have all these. You can see this parameter omega here represent the short-run coefficient, okay, for the lag dependent variables anyway. So we also have this one is also the beta high, okay, that's beta is also the short-run coefficient for the exchange rate, the short-run coefficient for inflation, okay. Then we have plus the Fourier terms, then plus error. I have an error correction term. You can see we have error correction term, then we have the coefficient side, then we now have the error terms, okay. Then we have the explanation, the note on error correction model. Mean the same thing, we have the same interpretation just like we have on the ARDL model as we discussed in day 1, okay. I won't waste time on this. Then we have the corresponding long run, so as defined in our previous class in day 1. You can see. Now let's move to STATA ARDL model. So I come back to STATA environment here. You can see this is STATA environment. Okay, then I've already set my working directory. So the folder where I have my do file and data set I want to use, I've already set it as working directory. Okay. Now the next thing I want to do, if you don't know how to do that, so just watch the one. So you are going to be guided on how to set your working directory to the right folder. Then when I want to open the do file I want to use. So I go to file, then I click on open. Then it will take me to that folder that I set as my working directory as usual. So because in this slide I want to discuss Fourier Fourier ARDL model. Okay, so this is the do file I want to use, FAARDL. So I click on that, then I open it. So I have my do file ready. This is the do file. Then the data set. I want to import data set. So let me just import data sets, okay, manually from file here. So let me go to file, then click on import. Because my data is in Excel format, so I click on import Excel. Then I click on browse. Then this here is the folder because I've already set this folder as the working directory. So I have my data set. So I click on open. Then I check this first box, import first row as variable names. Okay. So then I click OK. So you can see data set has been imported. Then I go back to my do file. Okay, the first thing to do is to set the data set as the first thing to do is to declare the data set as time series. Okay, to declare the data set as time series. So let me do that. If I declare data set as time series, I run the line of code in line 27. Then let me execute that. Okay, here. So I have my data set, okay, be declared as time series. Okay, I may want to view the data set. So let me just go back to environment. Then I type BR, that is browse in full. When I click OK, it will bring my data set. You can see this is the data set. Confirming that it has been imported. Then I go back to do file because the model I want to estimate is based on the log of exchange rate and the log of GDP. So I need a log. I need to log exchange rate and my and GDP and real GDP. Okay, so I need to log these two series. Then to log the two series, you can see here is the code. Okay, line 30 and line 31. So I execute that. So let me go to environment. So exchange rate and real GDP has been logged. Then I then have to, normally when you are carrying out your analysis, so you're expected to do, before you carry out the analysis proper to estimate the model, you're expected to carry out descriptive statistic and unit truth test. So, okay, so we have done that in our previous webinar. Okay, so you can refer to the previous webinar to know how to conduct unit truth test. Okay, so in this class, we are going to estimate just Fourier augmented ARDL model. So I'll move to Fourier augmented ARDL model. Here is the command we are going to use, ARDL. Okay, then followed by the dependent variable as we have in our model specification. Then we have the target variable, log of exchange rate, inflation. Then as a control variable, we have trade openness as a control variable. Okay, trade openness as a control variable. You can see. Then we have type. Type of the model we want to estimate is FAARDL. Then we set the maximum lag to 4. Then the maximum number of frequency. Okay, you can see in the specification where we will have the frequency in the Fourier terms. This K means frequency. Okay, so we set that to 3. Okay, maximum is 3. Okay, so hardly you can find a value that will have more than 3 frequency. Anyway, then AIC as our criterion. Then we have case, popular case, that is the unrestricted intercept and also no trend. Okay, let me run that. If I run this, okay, let me run that and wait. at this, you can see we have the Fourier terms here. Okay, and you can see for sine, it is significant, as for cosine is significant. It means that this Fourier terms is very important to be included in our model. Okay, anyway, if you come down here, you can also see the F start on the Fourier terms. So if this Fourier term is not significant, it means there's no point in using Fourier augmented ARDL model. So ARDL model is okay for analysis, because why are we going to include terms that are not significant? So if they are not significant, so we don't have anything to include them. So we should just use our augmented ARDL model. Okay, now let's go back to the we go back to our bond test. Before you can interpret your model, just go back to your bond test to check if there is actually long-run relationship. We can see these are the 3 tests, and the rule is that we should reject all the non-hypothesis for all the 3 tests before we can establish long-run relationship. You can see for F test for overall, we reject the non-hypothesis because this test is significant, okay, at 1%. This 3 star means 1%, 2 star means 5%, and 1 star means 10%. All these 3 sets are significant at 1%. So you can see the conclusion is that co-integration exists, okay, meaning that there's long-run relationship. If there's long-run relationship, so we can now interpret our long-run model. Here is our long-run model, but if the bond test shows that there's no long-run, there's no co-integration, so there's no point in interpreting this model here, okay, long-run here. So we just ignore that and interpret just the short-run. That is, if there's no long-run relationship based on our test, on our bond test. Okay, but for this model, we have been able to establish that there is long-run relationship. So we start the interpretation from this our error correction terms coefficient. This log lag 1 is our ECT lag 1 that we have in our model. Okay, in our model specification, you can see, you remember, in our error correction model, okay, in error correction model here, we have this psi, okay. So this ECT lag 1 is equivalent to this log of GDP lag 1, okay, and psi that we have is equivalent to minus 0.81, okay. So you can see, and don't forget to we expect this coefficient to be negative. Yes, it is negative, and the absolute value should be less than 1, and also the coefficient should be significant, and this meets all the three criteria, okay, meaning that because the coefficient of the error correction term is negative, less than 1 in absolute value, and significant. So this confirms the existence of long-run relationship among the variables, that is log of GDP, log of exchange rate, trade openness, and inflation. Okay, so and this coefficient indicate that about 81% of the deviation in the previous year is corrected in the current year. That is, speed of adjustment is 81%. That is the interpretation of this, okay. So, and we have the long-run coefficient. You can see for log of exchange rate, the coefficient is significant, okay, even at 1%. So based on this, we can see that the exchange rate has positive and significant impact on real GDP in the long run, okay, meaning that depreciation, exchange rate depreciation increases real GDP. That's what it means. And for inflation, the coefficient is not significant. Although the coefficient shows that it has positive impact on real GDP, but it's not significant. Okay. Then, because it's not significant, so we are not going to talk about the magnitude anyway. So here we move to trade openness. The coefficient is significant, okay, even at 1%. So, and trade openness has positive impact on real GDP in the long run, okay, in terms of magnitude, because this trade openness is in percentage, okay, and the dependent variable is in log form. So we are going to multiply, okay, we are going to multiply this. So I said trade openness is percentage, that it is not log, okay? But the dependent variable is log. To interpret this coefficient, the coefficient of the variable that is not log, that is the coefficient of the independent variable that is not log. So we are going to multiply the coefficient by 100. Why? Because the dependent variable is log. So when we multiply this 0.06 by 100, so we are going to have about 0.67% or 0.68%. Okay, so meaning that if there is 1 percentage point increase, because in percentage, 1 percentage point increase in trade openness will lead to about 0.68% increase in real GDP. Okay, let me take that again. If there is 1 percentage point increase in trade openness, it will lead to about 0.68% increase in real GDP in the long run. Okay, in the long run. So we are able to interpret the long run coefficient. Okay, so moving to the short run, you can see the focus is on log of exchange rate. Okay, so log of exchange rate, we have the coefficient here. Look at the coefficient here. It is not significant, okay, because the conventional value, the conventional significant level we adopt is 5%, so it's not significant. So we move to the next one, okay. This lag difference, this one and this one are significant, okay. Anyway, this because this one is significant and this one is also significant, so it means that in the short run, okay, in the short run, exchange rate has negative impact on real GDP, meaning that if there is depreciation in the short run, okay, depreciation in the short run will lead to a decrease in real GDP. Okay, it leads to decrease in real GDP. That's what it means. Okay, so you can see moving to the long run, you can see it turns to be positive. Okay, that depreciation leads to increase in real GDP. So this confirms that the existence of J-curve effect in this economy. That's what it means. Okay, we can also move to inflation in the short run. Okay, in the short run, throughout the short run, okay, you can see inflation also has negative impact, okay, on real GDP. Okay, inflation has negative impact. And moving to trade openness, okay, trade openness initially has positive impact in the short run, but later still in the short run it turns to be negative impact. Although in the long run it has positive impact, you can see. Okay, so we be able to interpret the coefficient. Okay, now we move to diagnostic test. Moving to diagnostic test, you can see we have Jacobera for normal distribution of the error, the test of normal distribution of the error. So the errors are normally distributed, and we also have BGLM test, okay, no serial correlation, so there is almost scarcity, so we are happy, and the model is correctly specified. So based on the diagnostic test, the model is okay, is good, okay. So we are able to interpret most of the necessary things, okay. Now moving to the half-life period, okay. You can see this is the coefficient of error correction time that we have. This is minus 0.81, okay, equivalent to what we have as our adjusted speed here, okay. And this half-life period that we have here, okay, the half-life period that we have here, that's 0.4192. So it's about 0.4, okay. So meaning that the half, if there is a shock, okay, if there is a shock to the dependent variable, that is real GDP, okay, it will take about 6 months, okay, or if you like, because this is not up to 6 months, this is 0.4. If it's 0.5, we will have said 6 months, because it's an annual data. 1 is equivalent to 1 year, okay. This is 0.4. It's not actually up to half 6 months, okay. So we say it leads to about 6 months. Okay, let's take it like that. It leads to about 6 months for the half of the shock to disappear from real GDP. Let me take that again. If there is a shock to real GDP, okay, if there is a shock to real, okay, the half of this effect will disappear within 6 months. That is what it means. So it takes about 6 months for the half of the shock, the effect of the shock to disappear from GDP. That is what. So you may want to also look at the graph. Okay, you can see this is persistence profile. You can see this line represents the half of where the half of the shock disappear. You can see, so it's equivalent to where you have 0.419. Okay, that we have. So you can also view the impact of trade openness. Okay, the impact of trade openness on real GDP. So you can see it's going up, it's positive. Okay, it's positive. Okay, it's positive. We can also look at this. That is long run. Okay, long run is also for inflation is positive. Okay, you can see it's going up. What of exchange rate? Exchange rate is also positive. Okay, so you can see it's positive. Hope that is clear. Okay. So that is how to interpret this. The interpretation is the same thing. Okay, the only addition is that of Fourier terms. Okay, to check whether that Fourier terms are significant or not. So it is significant. That is the only difference between interpretation of augmented ARDL model and Fourier augmented ARDL model. Hope that is understood. Okay, thank you. See you in the next class.